Hello, this is Workbook 26.1, Conditional Probability. We've talked about independence, like probability of independent events, but this is conditional probabilities. This is saying that we want to know the probability of this happening given that we know this specific thing. So for example, they gave this example. If we said, what is the probability in a normal deck of cards to draw a diamond? Well, there are 13 that have diamonds on them out of 52, reduces to 1/4. But if your friend said, I want you to pick a diamond, but I'm going to tell you that this card is red, then that changes things, because then we know that there are 26 cards in the whole deck that are red. Again, 13 that have diamonds on them, so therefore the probability is much greater, 1/2. That's a pretty good ability to guess that one. But then there is an actual formula. So we say and so let's go back to what they do is they go back to the beginning. If we knew independent events, we would just say the number of possible events of event B happening out of the total. Instead, this is the intersection. So let me just come down here. Remember this one, we had to calculate this. Adding all those up was the 21, this 21 that was right there. And then all the glasses were 12, right? 4 plus 8 is 12. 14 was for 8 and 6 together. So we went like this. So if we say the probability of wearing glasses, given that they played a sport, we go like this. So the top number is always going to be that intersection part. But then given that they're the sport, it's going to be the total number of people in the sport thing. So that's going to be 8. They do this long thing. 8 out of 14, which will reduce to 4 out of 7. Another way of doing this is you can get the probability of wearing glasses and the probability of sport, right? Yeah, of glasses, the probability of sports, right? Yeah, let me see. Divided by, the probability of glasses, divided by the intersection. So the intersection goes on top, divided by the probability of sport on the bottom. If you were to multiply those, notice that those two 21s would cancel out. Still get 8 out of 14, and you get 4 out of 7. So they gave this other example right here. How many elements are in the intersection? Well, there are 8. And then the number of elements in G, well, that's 12. And then we want to do the sport given G would be 8 out of 12, but then that would have to simplify to be, let's see, if we divided both of them, it would be 2/3. So 2/3. I simplify, it would be 2/3. All right. And then they have this other one using the alternate formula, but this is a different event. This is a different thing. For the sake of time, I'm only going to go right to the workbook. So a bookshelf has 24 books, which include 10 books that are graphic novels, and 11 books that contain animal characters. Of these books, 11 are graphic novels that contain animal characters. So there's the intersection. What is the probability that a book contains animal characters given that that it's a graphic novel? So here's the intersection, and then graphic novels are 10, so it'd be 7 out of 10. And then right here, Central Online High School, that many students have a dog, that many students have a cat, and that many students have both dog and cat. What is the probability that students who have a cat that also have a dog? So it's cat, this intersection, given dog. So 18 out of 45. Ooh, and then that will simplify. If you have Desmos, you can simplify that using Desmos. Let me show you how. What do I mean? If you have Desmos, everybody has Desmos. So if you type this in, you get, I think I might have to change things. Hold on. Okay, this next one, at an online high school, 45 out of 100 students have a dog, 30 out of 100 students have a cat, and 18 out of the 100 have both a dog and a cat. So what is the probability that the students who have a cat, so that means given cat, also have a dog? So let's see, the intersection again is 18. There are 30 that have a cat. So you can come into Desmos or any graphing calculator, do 18 divided by 30. And you notice that we get this decimal. Decimal is not what we want. So we can come over here, do fraction. It goes back to fraction. So we get 3/5. All right. Woohoo!